All right. Hello, everybody. Today we're going to be doing day 4 of Advent of Code. And today's first part of the challenge is, well, we get a word array list. This is how it looks for me. It's a bunch of columns, a bunch of rows of just the letters X, M, A, and S. And what we want to do is to find Xmas, so these letters in order, and we can find them either diagonally or backwards or in any sort of direction. So here's a X, here's a M, A, S. X, M, A, S, backwards. Now X, M, A, S, upwards, X, M, A, S, to the right. So in any sort of direction, we could find Xmas. So, whoops. So we can find it up, we can find it left, right, down, bottom right, bottom left, this way, this way. So that's 8 total directions that we have to check, for example, or that it can be written in. So this is what we're getting, right? This is the file that we're getting. And there's a bunch of invalid things here as well. And they kindly gave us only the valid Xmas letters. So if we look at them, all of these should be valid. So if we see Xmas, then it means, okay, this is a valid Xmas, and this X should be going somewhere else towards another MAS. So it does. With this M, with this A, and with this S, it's a perfect combination to make another Xmas. So each Xmas here is just a result, but we are not getting this result. We should calculate ourselves and see, okay, how many Xmas's are there? And we should count them, and we should return them. So that is today's problem. So we should take this entire thing, which I've already taken, and we should open this and put it in input. So I have it. It's a total of 140 lines, but a lot of rows as well. The row is quite large. And what we want to do first is to load the grid, of course. So let's load the grid. I'm going to make a function for this, just because we're going to be using more functions than usual here to be working with everything. So we load the grid. If we just define the grid real quick and make it into nothing, we open the file with open. Let's copy the relative path. I don't want to type all that. And then we want to read it, of course, and this is going to be as file. So we're opening the file right now, and then for every line in the file, what we want to do is to add it to the grid that we just made here. And we can do that by saying grid.append. And we could just give it a line, but there is one problem. Maybe there is new line characters at the end or something. So I'm just going to say .strip to cleanse it a bit. And then since this is a grid, we want to just give it a list. So we want to convert this into a list type. So we've converted that. And after we've gone through the whole for loop and the whole open, we want to return the grid. So this is the load grid function that we've just made. And presumably we're going to be using this in part 2 as well. So we'll see. Once we have the grid, what we have to do is say, let's say grid is equal to load grid, right? So we just get a function, a variable that has the function result in here. And then we pass this thing into, let's say we make a function that we will call count Christmas, okay? Then we will pass this grid to that function. And then we want to make this into a variable as well. So we want to make this into count is equal to count Christmas. And then lastly, we're going to want to print the count. So this should give us the right result after we make the count Christmas function. So let's make the count Christmas function. Define count Xmas. And then we want to give it the grid, of course. Okay, so now it doesn't really complain apart from this because we have to put something in here. So if I could just print nothing, this stops complaining. So let's start making this function. What we have to do in here is first let's define how many rows and columns there are, because we're going to be iterating through every step. So every step in this text file. So how do we define rows? We can just say rows is equal to the length of the grid. So that's how we can know how many rows there are. And to know how many columns there are, we can do the same thing, but when we say grid, we also say, for example, 0. So it's gonna take all the places where it's at 0 and then count all the way down. We can also say like 10 or 100, but like I'm not really gonna count how many there are, and it's just safe to always go with 0. But we could say 10 here, it doesn't really matter, we get the same result. We can test it later and I'll show it. And then we should give it, okay, what word do we want to search for? So the word that we want to search for is Xmas. And let me put it in caps as well, because that's exactly what we're looking for. And then since we're going to be looking for this, let's say we start at this X here, then we want to be looking for a M somewhere, X, M, A somewhere, and an X somewhere. So we're going to be looking 4 different times, 1 for each letter. So that means that we're going to have a word length, and it's going to be the length of the word. So, which is just 4. You can just say 4 as well here, but I'm gonna keep it to the length of the word. And then, of course, counter is equal to 0. So that's what it is right now. Now, what we want to do is define all the directions, sort of. So I'm just going to make a directions array. So directions or list directions. Nope, not that. Okay, and then for each place, let's see if I can just, whoops. For each sort of direction, I'm going to just specify the sort of X and Y coordinates, right? So if I can open Paint here, we're going to be having, so X and Y coordinates, right? X and Y coordinates, not a beautiful graph. But if we go 1 right to the X in the X direction and 1 up in the Y direction, it's equal to this, which is this one. If we go 1 down in the X direction and 1 down in the Y direction, then it's going to equal to this. So every combination of X and Y is going to equal to us in every corner from a center. And that's what we want. We want to check in every diagonal. So I'm just going to be defining the directions in X and Y coordinates, so to say. So let's say we define the 0 and the 1 first, which is the, let's think, right one, because we go 0 in the X direction, 0 in the Y direction, and 1 in the right direction. We have 1 and 0, we have, so just every combination basically, 1 and 1, and then we have, of course, 0 and 0, and then we have, or no, we can't, because that would be in the same place. So we have 1 and 1, and then the next one would be 1 and negative 1, because we have to be going backwards as well. It has to be possible to go backwards. So 0 and negative 1 would be another one, negative 1 and 0 would be another one. It doesn't really matter in what combination we put them in, as long as we put all of them in, and then it iterates through all the different corners. So negative 1 and 0, we have another one which is negative 1 and negative 1. What else? And then we have another one that's negative 1 and 1. And how many do we have? We have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and then 1, negative 1, negative 1, negative 1, negative 1, 0, 0, negative 1, and I don't think I put in 1, negative 1, so let's put this here, 1, negative 1, and let me put this here, so that we have all of the ones that start with 1, 3 with 1, 2 that start with 0 here, and 3 that start with negative 1. And we can think a bit later about what directions these are. It's gonna take a while to think about, so but when I publish it to GitHub, I'm gonna be writing these here. So these are the directions that we're going to be defining. And let's not forget the equal sign, that's why it was complaining. Now what we want to do is iterate through every place, so every row and column, one by one, and then be checking every direction, right? So if we have the, let me delete all this. If we have the grid, so this, let's say this is the grid, then we start here, we continue here until we finish, then the next row, next column, and so on and so on. It continues, and at every point I want it to go over every direction. So it's gonna go upwards and check, it's gonna go this way and check, it's gonna go this way and check, this way and check, this way, this way, this way, and then this way. And we make it do that with a for loop. So to check all the grid positions, we can make a for x in range rows. So we're gonna iterate through everything in the row. And then we're gonna iterate through everything in the columns. So for y in range columns, we're gonna, now that we're iterating through every position, right? In every position, we want to do something special, and we're gonna do for the direction in x and for the direction in y in directions. So for each this digit and this digit, we want to be sending these things to the a checker function that we will make. So check, and then we will be sending it the x and y coordinates. We're gonna make this function soon. Checker. We're gonna send it the x and y coordinates and what sort of direction to keep checking in. So we're gonna be sending the direction in the x axis and the direction in the y axis. And then let's say that that this returns true or false. So I can just say here, if this becomes true, then I want to say counter plus equals 1. Okay, so now we have to make the checker function, and we can make it above here actually. So I'm thinking, since the checker function will be using the word length and all of these variables that we're having, it would be good to have it inside the count Christmas function because it has all of these variables in. So actually you can nest functions, which is great. So we're going to be nesting this checker function here, which should be getting, let's see, x, y, and then dx and dy. And we're going to give it, we're going to make it loop over the word length. So the checker should be just checking somewhere at the start, and then once it starts somewhere, it should go in whatever direction we told it to. But from this start, 1, 2, 3, 4. It should not be going more than 4. Why? Because Xmas has 4 letters and it should never be going more than 4. And then in this function, we have to do 2 different things. Check if it's out of bounds and check if, well, we're finding the right letters or not. So first we can iterate through all the letters. So for I in range of word length. So iterate until 4. Sorry, I'm still a bit sick. We're going to make a new x and y coordinate for each time that we go through the next letter. So if we're at x, then it's just going to be the normal x and y coordinates. If we're at m, then it means we have to go somewhere in some direction. And what direction? Dx and dy. So we have to add together the x and the dx, and then the y and the dy. So we can make a new x, which is going to be the original x, and we're going to add, what is my plus? There we go. We're going to add the dx, but if we're at the s, for example, we're not just going to add one time in one corner. We're going to add it 4 different times because we want to get all the way. And how do we do that? We can just use I. So we take the I and we multiply it by dx, so we know by how many times we should be going in that specific direction. If it's 0, then it just means, okay, the x-axis shouldn't be changed, and it's just gonna result since dx is 0, 0 times I is going to be 0, so it's just going to be x. So new x is going to be the exact same thing in some cases. And that is if the x-axis doesn't move, then just the y-axis moves. Okay, then it means it's going to be just the up or the down movement, for example. So we're going to do the exact same thing for y, and I'm just going to replace these things, y, y, and y. So now that we know in what direction we're going to be iterating over our grid, we want to check if the position is not out of bounds. So check if not out of bounds, and then later we want to check if character matches. Check if char matches. So here we're going to be doing if let's see, if it is not this, and what I'm going to be saying here is, okay, if the new x is not less than 0, so less than or equal to 0. If new x is less than 0, then, well, it can't be. It's going to be out of bounds if that happens. So if this is not the case, then it's okay. It is not out of bounds. And it should be in between a range, right? So it should be between 0 and it should be between the rows for x. And for y, it should be for columns. So I'm going to be putting this, and I didn't type it right with a capital X. And also, we should be checking at the same time if y is not out of bounds. And if we say and, then both of these statements have to be correct. So for readability, let me just put this here actually. And the y part should be the exact same thing. So let me paste it, but this is going to be the y-axis, and instead of rows, because the y-axis doesn't check the rows, we should be columns. And I don't think it should be equal to here. I think it should just be less than. Yeah, because the index starts at 0, and if there's 10 columns and we're at 10, then index 10 is 11, so we're already out of bounds. So it should be less than, not less than or equal. Then if we do not go in here, if we are not out of bounds, we return false. Or if we are return false. Yeah. And then now let's think about if the character matches. So if the character doesn't match, actually doesn't match, then we're going to be doing if the grid at the position x, but not the x, the new x, and then also at the position new y. So if the grid at these x and y positions are not the same as whatever the word is, so we take the word, we take the word and we go at position I, because that's what we're iterating over. If we're at the first, at the 0th one, we're going to be looking for the x. If we're at the first one, we're going to be iterating over m. If we're at the last one, we're going to be iterating over the s. So that's what we want to find. If it's not this, then we return false. So we did not find it. That's not great. But otherwise, if everything else passes, then we should be returning true outside of this for loop. So if we checked through every letter, x, m, a, and s, and we check through, okay, it is not out of bounds in any direction that we gave it, or not direction, just, okay, this specific top left direction, it is not out of bounds, because we're going to be iterating over every direction in here by calling it 8 different times. And then it's going to be checking, okay, is this letter x, this letter m, a, and s for that specific direction that we gave it right now in the checker. And if it did not fail to do that, then once it finishes the for loop, we want to return true. So the checker has checked it and it found it. And it checks over every direction and it loads the grid in the beginning. So I mean, this should work. Let's see if it does. So I'm running it. Let's see if we get any index errors or something. or syntax errors. Okay, invalid escape sequence, backwards I. Alright, so when I run it, I get a warning that there's an invalid escape sequence, and apparently it's just because I don't have a slash, but it's just a warning anyway, so it doesn't really halt the program. But we can see that we're returning none, which means that the function that we call, so we call count xmas and then the count, and we print the count, this returns none. But actually we should be getting the counter, right? So let's see what's happening. If we look all the way down, yeah, this is where we add the counter, right? But we just forgot to actually return the counter. So return counter, and then now the code should be done. So we have the load grid, which takes the entire text file. Yeah, I looked a little bit over the day 3, and we also had a backslash, but we never got that error, which was weird because I'm getting it now. Not error, but warning. Anyway, so we're iterating over the entire input file and making it into a grid, so it's easier to work with. Then we call the count Christmas function, which has a bunch of directions, which it iterates over. So it goes over every single position in X and Y in the input file, and then it iterates through every direction, so 8 of them. And then it goes in the checker, which checks is it out of bounds, and is doesn't. And check if it doesn't match, then it returns false. But if all of this is true, then it returns true. So if it did find a Christmas, Xmas in any of the directions. And then we, of course, increase the counter. And when we're done with all of these for loops, we're going to return the counter. And if we run it, let's see if it works. We get 2575. And if I open Advent of Code, yeah, that's the answer that I got. So great. Now let's talk a bit about the time complexity. So the time complexity in this case is, well, we have a bunch of for loops here, but it's for X and for Y, which is the rows and columns. So it's R times C times, let's call the checker W. So how many times it has to check? It has to check 8 directions, and it has to do a bunch of computation for each of it. But W is just a constant. So actually we could not write that. And then we can say, well, if R and C, so if rows and columns, if rows and columns are counted as just chars, and char is equal to n, then of n. So that's the time complexity, and the space complexity is the same thing. It's R times C, because that's what we're storing. We're just storing the entire file. So if the characters are n, then space is also O of n, which is great. Now for part 2, let's see what's different. So yeah, apparently we have to search for just the letters MAS, but they have to cross each other, so it's cross mus. Very funny. And here's the same filled grid, but with only the correct ones. So there's an A here, and then MS in each corner. So it's a cross mus. So they can be in any orientation, the M's and the S's. So right off the bat, what I'm thinking is, let's delete this. Since we have an A in the middle, and then we have a X or a M, S or M, here, or here. So these are either M's or they are S's. We can actually just look for the A's and then check the corners. Because if instead we check a 3x3 grid for this pattern, but like we start here, for example, and we find an M, okay, great. And then this is going to be a S. But when we pass over this, we go to the next row. When we pass over here, we're going to see the S again, and maybe we're gonna mistakenly find the exact same grid, the exact same crossmus, which we don't want to do. but we know that the A appears only once in a crossmus, which is great. So actually we can just look for any instance where an A appears and then just check its corners, okay? If there's a valid combination of M's and S's. So there can't be a M here and also M here. The opposite ones should be M and the S, and then same thing here, but they can be in any combination. So that's how I'm thinking to do it. And it shouldn't be too different from the code that we already have. Actually, I can take the load grid and the print function. So we're also gonna be using part of this, maybe just this and the counter, but I'll take it after. So we're going to be taking this function and then the counter, which is 0 for now. But let me just rename this, because now we're not looking for the same thing. We're looking for x_mus. So we're going to be using this. We're going to be giving it some space here. And now we're not going to make like cardinal directions with x and y for each corner. We don't need that. We just know that it's going to be in the top left or top right or bottom left or bottom right. So it's still 4 different directions, but I'm going to take a little bit of a different approach. So I'm going to define isValid x_mus. And we're just going to give it the x and y coordinates. Now, there's 2 different parts that have to be correct. This M and this S have to be coupled together, and this M and this S have to be coupled together. But first, we also have to check if we're out of bounds. So we can check if we're out of bounds, check. And we can do this by saying, let's see. So if the x, if we do x minus 1, and it's bigger or equal to 0, yeah. So if it's not less than 0, then also y minus 1 should not be smaller than 0. So it should be bigger than 0. Let me put these in parentheses. So the x and y coordinates should be bigger than 0. That's what this means. And also that they shouldn't be bigger than the columns or the rows. So also, and that x and, okay, a lot of parentheses, but these go together. These x and y's go together. And then these ones go together again. So, and if x plus 1 is smaller than rows, and y plus 1 is smaller than rows. And it's not smaller or equal to then, because the index starts at 0. So if it's smaller than, we're already at how many rows the limit is. Right, x is rows, y is columns. Let's not forget that. Okay, so now that we're doing this, we're going to be checking, so let's say the top left and the bottom right. So I'm going to be making 2 different statements. So I'm going to be checking top left to bottom right, and then I'm going to be checking top right to bottom left. So we're going to be making 2 if statements here. So if the grid at the position, so the original positions are x and y, and then what we want to find is a m or s, m/s. This is not what we're going to actually write, but just for clarity. So if we found an m or s in one side, and then on the other side we find also a m and a s, so and this, then we should do something. So this is how the line is going to look for both of these. But in this case, so we want the top left. So we want to do x minus 1 and y minus 1. and then let's say that we want this to be the m. And then we're gonna do something similar here, but x plus 1 instead. And let's say y plus 1, yeah. So both of these, both x and y should be minus or plus, because if we're going top left, in this case, then we're minusing x and y. If we're going bottom right, then we're plussing both of them. And in this case, one of them will be plus, the other will be minus, and then it reverses. So let's do this. So x plus 1, and then y minus 1, and then here it's going to be x minus 1 and y plus 1. Okay, so if we found the m, then the second diagonal, the second corner should be a s, and same thing here. If we found the m here, then the second one should be a s. So that's what we're trying to find. But actually, there's also another case where this is the opposite way. So this is a m, and this is a s, and this is a s, and this is a m. I know it's a bit confusing. We could probably simplify this, but I feel like it's pretty readable as well. So let's see. So if the grid happens to have those combinations, we have to have both of these statements become true somehow. So actually, let's make a Boolean value first. So part 1 is equal to false. So we're going to initiate them as false. And then part 2 is equal to false also. And then in here, when these go in here, we're going to make them true. And then we're also going to make this true. Whoops. But we don't want it to go. So let's say, actually no, we can have both of them as if statements. We don't have to have a elif. It would work like this as well. And then same thing here, but here we're going to have part 2. And then also here, part 2 is equal to, whoops, true. True, true. Now, what we want to do is, after we check all of this and we go through the if statements, we just want to return. And since these are Boolean values, we can do a AND. So we return part 1 and part 2. This doesn't mean that we return whatever part 1 is and we also return part 2. So we return two things. That's not what it means. This means that we do a check between this Boolean value. So if this is true and this is also true, then we return true, which is 1. Otherwise, if either of these are not true, then it just returns false. That's what this means. It's a Boolean check. It doesn't mean that it's going to return two different values. So we return these two, and of course we have to iterate through every combination. Let's see. So let me just take this and put it here. So let's see. I'm going to put it right here. Are we not where we should be? Define as valid xmas. Yeah, so here we're not going to be doing dx dy, but we're just going to go through x and y, and then if the grid of x and y is equal to a, so first we're going to be finding an a in the middle. So if we found an a at whatever x and y position, then we're going to be calling is valid xmas. So and all right, we can call it right here, and if is valid xmas of x and y, then we do count plus equals 1. So instead of just calling it in a new row, I've just done it in the same line. So we call it right here actually. So if this is a and right, but it's gonna go over this right after. So actually, yeah, if this is a and if, so we want to check is there a, because even if there's not an a, if I put an and there, then it's still gonna check is valid xmas, and like we don't even want that. So if is valid Christmas, with the same x and y coordinates, then yeah, count plus equals 1, and we can keep the counter, the original counter that we had, and then we're gonna get it returned, and we're gonna get it printed. So this should be working. There's some syntax errors here. Parentheses not closed. So let's see, this parenthesis here, these two belong together. Yeah, this is -1 here, my bad. Yeah, that's what I was complaining about. So this belongs together, this belongs together, purple, 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 yellow, yellow. Great. And any problems here? This is not a plus, is it? It's a question mark. Man, this new keyboard is really... Or maybe it's just because I have a different language. Yeah, it was. Wow. Okay. Still having to get used to it. So part 1 and part 2 should be solved now. Let's run it, see if we get any errors. 1056. Ooh. I don't think that's what I got. I got 2041. Okay, so let's see what we did wrong. Alright, so we were having the wrong answer, not because of the bounce check and not because of the checks here, but because I wrote accidentally part 1, and then part 2, part 1. I forgot this one here. So this one should also be part 2. Let's see what we got before. We got 1000 something, which is not correct, but if we put it correctly to part 2, then we get 2041. And was that the answer? Yeah. So let's talk a bit about the time complexity as well. So let me go all the way down here and let's think. So this should be quite similar to the last one actually, because we're iterating through C if each C is the char. So time is O of char, so O of n, and then we just check a finite amount. There's no for loops here. We just check a finite amount, so a constant value, which we don't have to append to the n, and that's about it. So that's how this solution works. We don't have to iterate through a bunch of times going through each corner. That's why we don't have a for loop. We just check one time in one specific corner that we know. In this case, if we would give it the coordinates and then without making a for loop, would have to make a bunch of its if statements. If this one is here, and this one, and this one, and this one, and imagine for each different direction, it's going to be something different. So it would be a lot more different. So it's just a lot easier to do it with the for loop. But when it's just one different corner, we can solve it here with two different groups of if statements. These two are exactly the same, but it's just that the m and the s's are flipped. So if either of these are true and either of these are true, then both of these somewhere should be true, then it returns true. So we get the correct answer. And that is the time complexity, and then the space complexity is the same as this one actually. So I'm just gonna copy that, paste it here, and that is the space complexity for this problem. So that was the day 4 challenge. If you guys want to join the leaderboard, we have a private leaderboard. This is the code. I'm going to be putting it in the description as well. And there is a couple people that join actually now, so that's great. Thank you for watching, and see you guys tomorrow.